Okay, so we are recording. So you have to find the area, total area between the curve y equals x squared minus 4 and the x-axis for that interval. We did this already in the previous example, but using NINT. NINT, just so you know, stands for numerical integration. It's basically using the TI-84. Remember, we hit alpha, window, and then option 4. Remember, option 4 is FN INT. That's how it looks. You could also access this if you hit math. And if you hit math and then just scroll down, I think it's option 9. That's also where you can locate it too. And the reason it's called numerical integration, it's an approximation. So what the calculator is actually doing, it actually is calculating all these thin rectangles from A to B, whatever you define as A to B, and it's giving you that area. So it is actually and there's an actually more advanced process. I can't remember the name of it or what it's exactly doing, but that's what it is. So, anyway, so let's look over here. What function has this graph? If we think about it, it's actually the absolute value of x squared minus 4. Because you take the portion below the x-axis and flip it over the x-axis. And if you compare, so this was like a negative area. And of course, that was a positive area right here. Now, you have two positive areas when you do the absolute value. So will any of the curve lie below the x-axis? No, as you see right there. So the total area can be expressed like this. The integral from -1 to 4 of the absolute value of x squared minus 4 dx. So now you can just do that. The problem is that you can't do that analytically. So you must use the TI-84 to evaluate. And I trust you guys can do that just fine. So maybe I don't need to do a calculator demo. I trust you guys can do it just fine. So the total area of the curve, when you ask for total area, not net, the total area of the curve is the integral from A to B of absolute value of f of x dx. Whereas net area is simply just going to be A to B of f of x dx without the absolute value. So you got to do an absolute value transformation, as we saw over here. Oh, great question. How do you write absolute value? Same place. You go to alpha in window, and you should see a function called abs. So I think it's the first option. Actually, let me see if I can go to my other device. Let me maybe mute myself here. Okay, so I see myself twice and I hear myself twice. It's crazy. All right, can you guys hear me? Good. All right. Well, actually, I give myself a thumbs up. Okay, it's so weird. Wow. All right, like I clone myself. All right. Let me pull up the TI emulator. So what you would do is you go alpha, window, and there's abs, option 1. Oh, shoot. You guys can't see. Okay, can you guys see the calculator? Thumbs up. Good, okay. Yeah, so you go option 4, obviously. And you go from -1 to 4. And then you're going to do your equation, but you alpha window and you pick abs. And then it's x squared minus 1. Dx. And we get 19.33, which we got in the notes on the video. And by the way, if you try converting that to a fraction, it won't do anything for you because it's an approximation. So even though I know the answer was 58/3, it won't give you that. If you have a TI Nspire or a more sophisticated tool like Mathematica, yeah, it'll give you the exact answer, but these are, it's an approximation. So that's how you do it. Okay. Okay, now I'm back on my PC. Okay. All right. Let's share again. And looks like we're still recording. Okay. Now, one question that I wanted to pose to you guys, and actually let me pull up the fill.notes on my end here, so I'm not confusing myself. Hold on, spring semester, lecture notes, fill.notes, 6.4, there we go. Yeah, so will this be the same? If I do the apps value of A to B from apps value of fx, will it be the same as doing the apps value around the whole thing? This is a common misconception. The answer is no. They're not the same. And I'll give you a quick example of why they're not be the same. So remember what we just did, right? We did from -1 to 4 of f of x dx. Now, if you just did this, or sorry, x squared minus 1, if you just did that, you got 5/3. So if I do an absolute value around that whole thing, I get 5/3. If I do this, the integral from -1 to 4 of the absolute value of x squared minus 1, which I just did in the calculator for you guys, we got 19. We got 19 1/3, or 19.33. So there's not the same. Remember, this is actually total area. This right here is just net area . That's the value of the net area. That's all it is. So yeah, don't confuse that, please. All right, now this is a big one. And I'm going to ask something like this on our test over the weekend when I do a take-home test. And you're going to see this on the AP exam. I remember, last year when we were in the pandemic, people were trying to predict like what the College Board was going to do with the revised AP exam because they had to do it online. And there's actually a Facebook group that people subscribe to, and I check it out. I'm not on social media that much. I really don't like social media that much anymore. But I just kind of checked to see what people were saying and get some practice problems. And people were trying to predict what's going to be on the AP, and I was actually a little more bold. It's going to have FTC, and it's going to have I think I said differential equations or something like that. And I was just like very kind of arrogant with the response. And the moderator actually shut down the comments because you guys cannot speculate and we don't know, and this is like blah blah blah. I'm like, whatever, dude. We know what they're gonna ask. I don't know why that person's so bent out of shape, but this is something that, but it did. Well, I was right. It did show up. I mean, that's what they like. They like this kind of stuff. And in fact, if you go to the College Board and look at old AP exams, you'll see something like this pretty much every year. And it's always in free response. So h of x, let's say h of x equals this. Okay, so we'll be hypothetical. H of x equals integral from 1 to x of f of t dt. Fine. You can see something like that. And once such a function is given, the problem may go on to ask several questions about it, even old stuff. old stuff, like find me the absolute maximum, find me the points of inflection. So this requires you to know stuff from the previous unit. Remember from week 1 actually, where we did like inflection and increasing, decreasing, all that stuff. Last unit, was more Riemann sum stuff, obviously, and MBT. So let's look at this one right here. Let me kind of walk you through A and B, and they're out of order, C, D, E. And then at that point, it might be good to take a little break. So let G be the function given by that. Okay. So that's, sorry, G is this function right here. Sorry, G is an integral, my bad. G is an integral from -4 to x of f t dt. That's a graph of f. My apologies. And they're asking for G of -1, G prime -1, and G dou prime -1. Well, here's what you do. G of -1 is easy. You simply integrate from -4 to -1 of f of t dt. Let's do that. You got the graph of f right here, going from -4 to 1. So let me shade the area for you. Here is the area that I'm shading. I want all this area here. Okay? And let me partition if that helps. You got a right triangle. You got a little rectangle here. So you got 4 regions. And remember, you're going from left to right. So you're not reversing the order of integration, but it's going to equal area 1 plus area 2 plus area 3 plus area 4. So find me those areas, and these 3 right here are going to be negative, just so you know. Question in the chat. Oh, was it to -1 or +1? Oh, God, goodness. Okay. False alarm. I wanted to go to positive. I don't know why I want to go to +1. Let me clear that. Okay. Oh, goodness. Yeah, it's going to -1. You guys are correct. My apologies. G of -1 is from -4 to -1 of f of t dt. So take 2. Okay, so we're going from here to here. So I can now partition this like that, and I'll shade so you know exactly what we're finding. So yeah, tell me what that area is. And it's going to be negative. So someone wouldn't mind sharing in the chat what do you think that area is going to be? You got a right triangle and you got a rectangle. What do you got? I hear -7.5. Let's see if that makes sense. I got -13.5. Okay, so we have a discrepancy. Let's see who's right. So this area here, obviously, the triangle, this is 3, and that's 1. Remember, the whole thing's gonna be negative because all of it's below the x-axis, so it's 1/2 times your base times height for the triangle part. And then you got a rectangle, that's 3 by 2. So that's 1.5 plus 6. Yeah, should be -7.5. So please be careful with your work here. Good. Okay. -7.5. So that's pretty easy. Now let's look at what this is asking you to do here. This is FTC part 1. That is FTC part 1 at its core. You want G prime -1. Well, if you think about it, G prime of x is the derivative of this integral here. And we talked about when that happens, they cancel out and you just replace t with x. So it becomes just f of x. So G prime of x is f of x. So what's G prime -1 now? f of -1. Well, what's f of -1? You got the graph right there. So the answer is just -2. So before I move forward, do you guys see what I just did? When I ask for g prime -1, g prime of x is f of x. In fact, you may even want to start by doing that before you do any parts. G prime of x is f of x because g of x is the integral of f of x. So if you do the derivative of g, you better do the derivative of the integral. If you do the derivative of integral, they cancel out. You just get the function that's in there, which is f of x. That's FDC part 1. And so, yeah, you want f of -1, just look at the graph. It's -2. That's it. -2, sorry, not +2. Then if you want g double prime, well, guess what? If I want g double prime of x, that's f prime of x. So if I want g double prime of -1, then I want f prime of -1. Here's the problem, though. We have a sharp corner. I can't find the slope of that tangent line. So we say it does not exist because you got a sharp corner at x equals -1. So it doesn't exist. By the way, something like this on the AP exam would be worth 3 points. You get 1 point for g of -1, 1 point for g prime -1, 1 point for g double prime -1. So they give you 1 point for each. They don't get partial credit. So if somebody made a careless mistake with g of -1, sorry, you get nothing. If you made the mistake where I accidentally put 2 instead of -2, sorry, you get nothing. So yeah, be careful. Of course, you'll get points for if you get like the first 2 parts right and the third part wrong. You get 2 out of 3 then. But they don't do partial credit for each part. Okay, any questions? Nope. Okay. For part B, now for the function g defined in part A, find the x-point for each point of inflection of the graph of g on the open interval. Okay, for point of inflection is when, remember, for the graph of g, we don't know what the graph of g is. I don't know what that graph is, but that's okay. Because what I need to know is I need to find where g double prime changes sign. Well, g double prime, remember, equals f prime. So where does f prime change sign? That's what they want you to do. Where f prime changes sign, because you have the graph of f. That's what you got to do. And remember, the point of inflection of a function g is a point where the graph has a tangent line, where the graph of f. So if you want to see where f prime changes sign, you have to see where the slopes of the tangent lines to f of x change sign. So you have to see where the slopes of the tangent lines of f of x change sign. Well, we have the graph of f. Let's scroll up. Okay. F prime is positive here. F prime is positive here. F prime is negative there. So where does the slope change sign for the graph of f? Right there. So that's what you're going to say at x equals 1. So here's how you would type this actually using the proper language. You'd say there is a point of inflection at x equals 1 for the graph of g because f prime changes sign at x equals 1 on the graph of f. Okay, let me let you guys see that text box. And because you made a statement earlier, part A, or you could do it right from the beginning. You could say, G prime equals F and G dot prime equals F prime. The people who grade it know that you've made that connection already. So they'll assume that you know that when you go on to part B. So if you say, hey, there's a point of inflection x equals 1 for the graph of G because F prime, because you know that that G prime equals F and G dot prime equals F prime. So so then the assumption is that when you say F prime, they assume that you're talking about G prime because you made that connection. And of course, the F prime does change sign at x equals 1 on the graph of F because the derivative is positive before you get to 1 and then negative afterwards. This will take some time to sink in, and you guys have a chance to practice it. We'll spend a lot of time talking about it on Thursday. It is new, obviously, but that's what they want you to do, is be able to interpret the stuff correctly. So if you had a little hard time with the interpreting of the graphs in the first unit, talk to me. Come by during office hours. I actually will make myself available in office hours this Thursday with Ms. Vach, because this is a little tricky stuff. Let's keep moving here. Okay, good. I repeated the graph. Let's do part E, then we'll do CD. I know it's going a little out of order. So CD, they don't ask this, or they didn't ask it, but they could have. This is for the 2005 AP exam. It's actually spring before I started working at Sacred Heart. Anyway, find the maximum values of G where this is true. So if you want to find the maximum minimum, if they just say maximum minimum, you have to assume absolutes. That's what they want. You have to assume absolute extrema, which means you'll need endpoints and critical points. Which means you're using the extreme value theorem. Well, here's the thing. And you're doing it for G, obviously. So first you could say EVT applies to G since it's continuous. And we're going to look at the interval from -4 to 3. They should have actually stated the interval as well. Here's the thing. How do I know I'm continuous? We weren't told that explicitly, but how do I know? Anyone want to explain how do I know? You didn't say so in the problem. Not so much the graph, because I have a graph of F. Thank you. Thank you, Lauren. G equals the derivative of F. This means that G is differentiable on that interval. So guess what? If it's differentiable, is it continuous? Yeah. Continuity is guaranteed when you're differentiable. We talked about it back in the fall. Because G equals a derivative, so it's got to be differentiable. How do we know that? We don't know what the graph of G is. We don't. That's the beauty about fundamental theorem of calculus, is that even if you don't have the graph of something, if you have the graph of its integral, you could still use fundamental theorem calculus to answer questions about G. So that's why we're using fundamental theorem calculus, because yeah, I don't know how the graph of G looks. It's impossible. But because you know the relationship between G and F, and you have the graph of F, remember G is the integral of F. If you do the derivative of G, that's going to equal F. So you can start answering questions about G by using fundamental theorem calculus. And again, I know that G is going to be continuous because it equals, you know, I could take the derivative of this, and it's going to equal F. And if you look at F itself, you know, obviously that is continuous. But the real reason why is because you can take the derivative of G, and G is differentiable. If something's differentiable, it's going to be continuous. So we're fine. Next up, you have to then plug in your so you got to make a little table here. We're going to plug our endpoints, -4 and 3, and we got to find our critical points. To find your critical points, that's when G prime equals 0 or does not exist. Well, remember, G prime equals F. So you want to see where F equals 0. F equals 0 right here and right there. And F, of course, exists everywhere. Another reason why this is continuous, so why G is continuous. But anyway, because G prime is going to be differentiable everywhere. So you get 0 and 2 as your critical points. F equals 0 at 0 and 2. So you're not looking for where the graph of F prime is 0. You're looking for where G prime is 0 and G prime is F. So you're looking where F is 0. So you have to think a little differently. Now I want the where the y coordinates is 0 for G prime to be 0, the y coordinates of F. And then you just simply plug these into G of X, because you're trying to find the absolute min and max for G of X. So in this case, let me erase some of the, or let me just do green. So to do this one, you have to integrate from -4 to -4 of f of t dt. Well, that's a 0 when the limits are the same. Now let me integrate from -4 to 3. That's going to take a while. I'll come back to that one. Let's integrate from -4 to 0. And let's integrate from -4 to 2. Okay, let's integrate from -4 to 0. If I do that, if I do all this area here, I know part of it was, I know this part is -7.5. That's going to be 2 times 1, so it's going to be -1, so that's -8.5. Because you have another right triangle there. If you go up to 2, this area is going to be base of 2, height of 2, that area is going to be 2. So it'll be -6.5. And if I go to 3, it's a little sliver right here, which is an area of -1. So if I add all that up, -7.5, -1, 2, and -1, I get -7.5. So in this case, my absolute max is going to be 0 at -4. My absolute min is going to be -8.5 at x equals 0. So that's how that one's done. And again, it might be a little confusing. You add the video to watch again. We're going to practice this when we come back from our break. You have homework on this too. We're going to talk more about this on Thursday. I'm glad I'm doing it earlier in the week, by the way, because it is a little crazy. But let me put this as a text block and how I would want you to write this. So you would say absolute max of 0 at x equals -4. And you say absolute min of -8.5 at x equals 0. And your justification is already taken care of because you said EVT applied to G. And again, G is going to be continuous because G prime equals F. And because F is defined everywhere, in our interval, then G prime is defined everywhere. And if G prime is, if your derivative is defined everywhere, that means G is differentiable everywhere, you're continuous everywhere. Remember, if your function is differentiable everywhere, so is your, so it will be for continuity. And remember, for EVT, you look at endpoints or critical points. So, and our endpoints are -4 and 3. So we plug that into the G function, which is the integral of -4 to x of f of t dt. We plug in our critical points, which we found to be 0 and 2. Remember, our critical point is when G prime is 0, and remember G prime is f, so it's really where f is 0 on the graph of f. I know you have to kind of think a little bit differently here. It's definitely abstract. I will say that for sure. This is super abstract stuff. This is what separates this class from non-AP. I'll tell you right now. The non-AP kids don't do this, or those who do not to bash on non-AP. I've taught that class. It's a good class, but those that don't do advanced calculus don't talk about this stuff. This is the big leagues here. This is not single A, double A, triple A. This is Major League Baseball here, straight up. So you have to really think abstractly here. That hey, G prime is f because G equal the integral of f. So G prime is f. If I want G prime to equal 0, I want f to equal 0. F equals 0 because we have the graph of f at 0 and 2. So I plug that into my G function, which is the integral of f. Again, work it out using area. And I see that the lowest is -8.5, the highest is 0. Let's do maybe a couple more, and then we'll take a break. I think it's a good time to take a break after all this crazy stuff we're doing. Let's look at C and D. I'll leave it kind of like this so you can see the graph. So here you have the integral from x to 3. Find all values of x in a closed interval where h of x equals, so h of x equals that. Well, obviously it's going to, x equals 3 because the integral from 3 to 3, that's an easy one. Of f of t dt equals 0. Let me write that more neatly, sorry. We know that for sure. If you think about it, you're accumulating area, right? This is area accumulation. That's what this is. Area accumulation. That's what's going on there. So all this area right here was negative 8.5. And we really can't counteract it over here. So I'm gonna have to kind of start it somewhere else. So you have to get a little creative here. It's actually a little tricky. You have to use a little bit of intuition here. Because you're going up to 3, and that of course is -1. That'd be a good place to put the integral. So x equals 1. For sure. Also over here, because that's also an area of 1 from 0 to 1, and that's an area of -1. So also at -1. You don't have to really give a justification. I just felt like doing for x equals 3. But if you were to integrate from -1 to 3, all the areas would cancel. If you integrate from 1 to 3, the areas would cancel. And of course, if you integrate 3 to 3, the lower upper limits are the same. So that's how that one worked. That requires just some intuition and thinking about area as well. And then lastly, for part D, where is it decreasing? So remember, we have h right here. So h is decreasing when h prime is less than 0. Well, here, h prime of x, well, you gotta do this first. H of x, you gotta reverse it. A lot of people forget to do that, believe it or not. They forget to reverse it. We actually had this on our final exam for the spring, and almost all my students forgot to reverse, but that's why I did the final before the AP, and I would tell them, dude, you gotta remember that, and then they define the AP. Then h prime of x equals negative f of x. So in this case, if you want h prime to be less than 0, that means you want negative f of x to be less than 0, or f to be greater than 0 because you got flipped inequality. So now you're looking where f is positive, which is positive from 0 to 2, and we leave it as an open interval because you got to keep f positive. And that would be your reasoning, because f is positive on that interval, and h prime equals negative f. And of course, you want h prime to be negative. So if f is positive, then h prime would be negative because h prime equals negative f. So, okay. Yeah, not stuff I really feel like I want to accelerate, but you know, this is what we're doing. Let's take a break. Let's come back at 10:25. Let's do some practice problems. Maybe what I'll do is I'll maybe do another video on 7.1. Maybe I won't start 7.1 today. I think we should do some practice of this stuff. We'll see. Let's see how. Let's do a 10-minute break. Let's come back. Let's do some practice problems of this stuff. Maybe I could squeeze in a little bit of 7.1 at the end. So we'll come back at 10:25.